Self-driving cars, lifelike robots, and autonomous delivery drones are the sexy, headline-grabbing face of the digital transformation that we see all around us today. None of these would be possible, though, without data, the oil of the fourth industrial revolution, and the analytic technology we've built to allow us to interpret and understand it. Big data is a term that's come to be used to describe the technology and practice of working with data that's not only large in volume but also fast and comes in many different forms. For every Elon Musk with a self-driving car to sell, or Jeff Bezos with a cashier-less convenience store, there is a sophisticated big data operation and an army of clever data scientists who've turned a vision into reality. The term big data itself may not be as ubiquitous as it was a few years ago, and that's purely because many of the concepts it embodies have been thoroughly embedded into the world around us. But just because we've heard about it for a while, though, doesn't mean it's old news. The fact is that even today, most organizations struggle to get value from a lot of the data they have access to. As a business practice, it's still very much in its infancy. So here's my look at some of the key trends that will influence how data and analytics are used for work, play, and everything in between, this year and in the near future. AI drives deeper insights and increasingly sophisticated automation. Artificial intelligence, AI, has been a game-changer for analytics. With the huge amount of structured and unstructured data generated by companies and their customers, even automated manual forms of analytics can only scratch at the surface of what's to be found. The simplest way to think of AI, as it is used today, is machines, computers and software, that are capable of learning for themselves. For a simple example, let's look at a problem we might use a computer to solve today. Which one of our customers is the most valuable to us? If we only have traditional, non-learning computing available to us, we might be able to take a stab by creating a database showing us which customers spend the most money. But what if a new customer appears who spends $100 in their first transaction with us? Are they more valuable than a customer who has spent $10 a month for the past year? To understand that, we need a lot more data, such as the average customer's lifetime value, and perhaps personal data about the customer themselves, such as their age, spending habits or income level would also be useful. Interpreting, understanding, and drawing insights from all of those datasets is a far more complicated task. AI is useful here because it can attempt to interpret all of the data together and come up with predictions about what the potential lifetime value of a customer may be based on everything we know, whether or not we understand the connections ourselves.